All right, hello and welcome to this workshop for Hack at Home about Git. My name is Nick Young and I'm a rising sophomore at Brown University studying math and CS. And today I hope to teach you about Git. By the end of the workshop, I hope you'll be able to use Git in your Hack at Home project and in software engineering going forward. So before we go on and talk about the specifics about Git, I want to talk a little bit about what Git is and specifically how it came to be, how you can use it, and what it's sort of similar to. So Git was developed by Linus Torvalds, the creator of Linux, a while ago, and essentially it's a version control system that's optimized for code. In that sense, it's really similar to Google Docs, to Google Drive, and a little bit like Dropbox, in that it lets you upload files and track changes along those files. It's really essential to modern development and it's used by millions of developers every single day. And pretty much if you want to get into computer science, you will at some point need to learn how to use Git. So essentially, what is version control? So let's say you wanted to try something new in your code. Maybe you wanted to try a new feature or you wanted to fix a little bug and you didn't really want to you wanted to make sure that your old version of your code didn't break when you went and changed something new. So what you could do in your text editor is you could save all the files, you could create new copies, you could and then make your changes and see if they work. And if they don't, you could just move back to those old copies. But that's really time inefficient and it can get really messy. What Git lets you do is it lets you store old states like save files and iterate safely, among many other things. Git also lets you create new branches that you can later merge into the main code base, whatever you might want to call it. It lets you collaborate with lots of other people when you make repositories shared. Git is a really, really powerful tool, and it will be incredibly essential, especially as the hackathon is remote, for collaborating with your peers. So how specifically does Git work, and how can you use it to track code, track changes in your code? So essentially how you use Git on the most basic level is that you first create a repository, which is basically just a collection of files. It's think of it as like a folder in Google Drive where you can throw things in, take things out, and track all those changes along the life cycle of those files. You create a repository, and then you add files to this repository. After adding your files, you can commit the changes that you've made to these files to the repository, kind of like imprinting what the files look like right now on a timeline. That's what committing means. And then if you so desire, and if you so set it up, you can set up your repository on GitHub, on GitLab, on Bitbucket, and push or pull changes from that remote repository such that you have backups online and other people can collaborate with you. And one really big distinction to make between Git and GitHub is that Git is like a tool. It's what actually tracks your changes. It's what actually you create the repository with. Whereas GitHub is the actual platform on which you host a lot of the repositories that you might create through Git. I like to think of it as Git is to GitHub as video is to YouTube. Git or video is like the thing that exists on your computer, and GitHub or YouTube is like the platform that hosts that thing. It's not that simple, but this is a really good way to think about it. GitHub is not the only remote repository service. There's also GitLab, Bitbucket, SourceForge, just plenty of others that do pretty much the exact same thing. But GitHub is one of the most popular ones, so that's why we'll be diving a little bit into it today. It's an incredibly powerful tool that will be super, super, super useful in your development going forward, and I hope that this workshop helps you learn how to use it. So here are some resources that you can look at if you want to learn a little bit more about Git by yourself. The first link is a link to where you can install Git, which we're going to be doing right now. Next is the link to GitHub, which you might want to make an account for when we go talk about GitHub. And then the last two are some really nice, really, really pretty guides on how to use Git. So without further ado, let's jump into the code, or not the code, just into the demonstrations. I want to first talk a little bit about how you can install Git. So you can go to git-scm.com, and depending on your device, you can just sort of download the correct version and install it, and you'll find that it'll pretty much work out of the box. If you have any trouble with that, we do have a Slack you can ask questions on for us to help you. But before we sort of mock install, since I already have it installed, Git and make sure it works, I want to introduce something called the terminal. And essentially what the terminal is it's your gateway to many more functions on your computer. Typically, if you wanted to look at files, you would use the file browser. If you wanted to open up an application, you would do that in the respective application. But there are certain things that a programmer needs to do that can't really be done through those conventional methods. Yeah, for example, like say I wanted to use Git, and yes, there is a GitHub desktop application, but there's a lot of little nuanced things that we might want to do on Git that might be a lot harder to do on that application. Essentially, by having a command line interface, which is what the terminal is, to execute commands, you can do things that you wouldn't otherwise be able to do nearly as easily with the graphical user interface. But yes, the terminal. I don't want to go too much into depth into how the terminal works, nor how to really use it. I just want to give some basic commands so that you're able to use it, if you do need to. So the first basic command we'll learn is pretty much how to find out where you are in the terminal. To do that, you just type in pwd, which stands for present working directory. Right now you can see I'm in a little folder called Git Workshop that I've created just for this workshop where pretty much we'll just be doing a demonstration. If you want to print out the contents of this folder that you're in, you can do ls, which is basically like list, I think you could think of that as. Right now there's nothing in the folder, so nothing to see there. But let's say I wanted to create a file, touch to create a file if you're on Linux or Mac. I create a file called abc.xyz list, and I can see that file right there. I'm gonna remove that file so that it's gone now. So rm for remove. If I want to move around, I can go to the directory right above this one, so the one that contains Git Workshop, by doing cd, change directory, and 2 dots. Now I'm in a scratch directory, see what's in here. I got a couple of things going on. I can go back into Git Workshop, and that looks pretty good. And yeah, as you can see now, I'm back in Git Workshop. Those should be the main terminal commands you need. We'll attach a link to a resource so you can learn more about Unix commands. If you are on Windows, the commands will differ slightly, but they shouldn't be too hard to figure out. A quick Google search should reveal the correct commands. But cool. So now that you know pretty much how to use the terminal, we want to check that Git's working. After you've installed it, you can expect to just write the word Git, and you should get this whole slew of like Git commands. If Git did not install correctly, you might get something that looks like this, like Git command not found. Should that be the case, obviously the installation didn't work, so you can ask us on the workshop Slack how to get that working, or you troubleshoot it in some way on Stack Overflow or something. But essentially, yeah, once you have Git working, you can click Git, you can type Git, and you can see a lot of help stuff here. But we're not going to be using this right now because we have a workshop to help you through learning Git. So what I want to do now is I want to create a repository. I said earlier that the first step to using Git is to create a repository. And pretty much in order to do that, you basically want to write git init. And what that does is it initializes a empty Git repository in the folder that you're in right now. So essentially what that means is that now I can start tracking files in the folder that I'm in like when I ran git init. If I run ls, you'll notice that there really is nothing in the folder. But if you want to see like hidden files, which is what Git will be, a hidden folder, you can add -a, and you can see that Git has been added to the list of folders in this directory. So cool. Now that I've initialized a Git repository, well, what can I really do with this? I said earlier that I can add files, I can track changes, but right now haven't really done anything. So something that is really useful for Git is if you write git log, you can see all of the changes that has happened in your entire history. So far, nothing's happened. So there are no commits. So there's nothing really going on. So it just says there's an error. But once we start adding stuff to the Git repository, it'll come up with some semantic meaning, some stuff coming up. So I used touch earlier. I'm going to use it again. I want to touch a file called hello. So what happens now is that there's a file called hello. And what I want to do is I want to track this file. I want to track changes to this file such that, say like there was something valuable in this file. Right now it's just empty, but say like I had a script in there. I want to save this file for later, and I want to add it to my Git repository. So first I want to check what does Git see? What is Git thinking, and what has Git detected so far in the folder? What I'll do is I'll run git status, which gives me the status of Git in this particular folder. You'll notice that right now, Git reports that there's one untracked file named hello. what that means is that Git like notices that there's a new file there. It's incredibly smart, but it hasn't, like you haven't added it to Git yet, which we're going to do in a second. Just so that we know that Git isn't just like, this isn't a hard-coded value, I'll add a new file called goodbye. We'll run git status again, and we'll notice that there's an extra file there. I'll remove goodbye, just so that we can deal with one file at a time. Cool. So now I want to add this file. So to add all files that are in your current directory, you can just run git add and dot. Dot just stands for like everything in this space. No errors, which is good. So now we're going to run git status and see what the status is. Now we see that this file has been tracked by Git, and now it just needs to be committed. There's a new file, and now all we have to do is commit it. In case you did want to unstage it, so you didn't want to track it anymore, you could either do git reset, which would make it go untracked again. Let's say we add it back. Or you could use git remove cached and then hello. And it'll do the exact same thing, except git reset will untrack all of the files at the same time. But cool. Back to here where we've added it. And we have one file called hello, and it's being tracked. So now we want to commit it. So adding the file to the repository isn't enough. We actually need to tell Git to create sort of like a snapshot of what your file structure looks like right now. And how we do that is we do that through commits. And as we'll see with git log in a second, the commits are arranged in a history, a linear history, where you can sort of see the stage of the program at every single point in development, which helps you reason about what was going on and what changed over the course of development. So what we're going to do first is we're going to commit, git commit, and every commit needs a message. So you need to do -m, and in quotation marks, write your message. We'll do initial commit. And you can write anything in here. Typically, it's best practice to write a good, semantic, and meaningful commit message so that when you look back on your commits, you can see like what happened, because you don't really want to comb through the files. Yeah. So we're going to commit it. Notice that there was one file changed and something's been created. And if you go run git status, you'll notice that nothing to commit and working branch is clean. So now if you run git log, you'll notice that there was something going on. There is one commit, and this is basically how you can see your history throughout the changes that occur through Git. So now what I want to do is I want to do a couple more commits. I'm going to add goodbye back to the file structure. We notice that it's untracked. We're going to add it to Git with git add. We're going to see, okay, now it's been added. Now we just need to commit it. Now I'm going to commit it, and I'm going to write second commit. So now with the second commit, there should be a second commit in the log. And now we see here that we have the initial commit and we have the second commit, which is really good. It's what we were looking for. Let's say I made a breaking change. Let's say goodbye was actually not a good change to make. Maybe it broke a lot of features. Maybe I just didn't want it to happen anymore. What we can do is we can git log. We can copy this commit ID, and we can run git checkout to this ID. And what this will do is it'll basically like put you to where that commit looked like. So notice that right now we should have goodbye, but right now we only have hello. And that's how we can sort of revert back to earlier places. There's a lot more details here on how you actually would finalize those reverts, but essentially in essence, that's the main idea of how you would go about reverting. But we're going to go back and check out back to master, which should have our goodbye there. Cool. So now we have an idea of how to add, commit, sort of check out, status. We have a good mix of commands underneath our belt for Git. And honestly, 95% of the time, those are the only commands you're ever going to be using. You're just going to be adding files to your Git repository. You're going to be committing those files into the timeline, and that'll be the main thing. Now, of course, having a Git repository on your local branch only isn't so useful. Oftentimes, what you want is to actually, use an online service like GitHub to share your repository with other people so that they can collaborate with you on your code. So what we're going to do now is we're going to explore a little bit of how GitHub works. We're going to add this to an online repository. And yeah, we're just going to jump right into it. So I already have a GitHub account, so I don't need to make a new one. But I highly recommend that you make a GitHub account. Once you do, you'll be prompted with a screen that looks like this. And you can head to your repositories, or you can click new right here. So what I'm going to do now is I'm going to create a new repository. I'm going to call it maybe just like Git example. Make it public. I don't want to add any of these things, and I'll just create the repository. And this is markedly distinct from creating a repository on your local drive. What you're doing here is that you're creating an online place where you can put your repository, where you put all your files in GitHub, not on a local device. So if you didn't add any of the other stuff, you'll see this quick setup guide. And we're just going to learn how to add this to our repository. So what we want to do first is we want to copy this. This is sort of like it's just a link to your repository. And we're going to bring it back to our Git folder. So this is the same folder we were in before. It has the goodbye and hello files. And what we want to do is we want to somehow link this repository to the remote repository on GitHub, this one. How we do that is we do git remote add origin, and then we will type in that URL. No errors, that's good. What is this doing? What it's doing is it's saying, okay, Git, I want you to look, we're gonna do something with remote repositories. I want to add a remote repository, and we're gonna say that the origin is this. So what happened? Why is this, what happened? Essentially now our Git repository on our computer is now able to communicate with that repository that I have here on my browser, which is super, super, super useful, because now if I look at my Git status, everything might be committed, everything is saved locally, but I want to make a backup. So how we do this is we do git push, and git push is the command for pushing things to a remote repository. And what we'll do is we'll do git push origin master. So origin is just the name of this remote branch. You could have different names for different remote branches, but typically it's just called origin. And then master is the name of the branch that you're looking to push. You'll notice that when we were on git status, we were on branch master, so that's the branch we want to push to for now. So we're gonna run that, and it's pushing, and voila, you'll notice that GitHub was able to make a new branch, or notice that you created a new branch master, and it's now tracking those changes. So if we want to refresh this Git example repository now, you'll see that we have goodbye and hello files in here. Obviously, they don't have anything in them, but yeah, they exist in the file system. You can track them online. You can go to your settings and you can invite collaborators here. GitHub as itself is already an incredibly powerful platform. I don't think that we have the time to go through all of its exhaustive features today, but I highly, highly, highly recommend getting incredibly familiar with Git and GitHub as soon as you can. It'll really make your developing life a lot easier. But yeah, those are all the main things that I wanted to go through in this workshop. I hope this was really useful. Before we finish, I want to address one thing, and that's the use of graphical user interfaces for GitHub. I don't have one installed on my computer, but typically a lot of people when starting out on Git will opt to use a graphical interface, which is pretty much just like an application window where you can click instead of type, to basically act as a proxy for Git. And that works. I have no real qualms against that. I think that if it works for the developer, then there's really no issue there. The only thing I will say is that it really is a good skill to have to be able to use Git via the command line. I would heavily, heavily implore you to try and learn how to use your computer's terminal, whether you're on Mac or Windows or Linux like me, and get familiar with using it. Once you get really comfortable in the terminal, not only can you look like a really cool hacker in front of all your friends, but also it'll make a lot of stages of development later a lot easier. With that being said, if you have any questions about this workshop, please feel free to go to our workshop Slack channel for this or any later workshops. Please feel free to go to our workshop Slack channel and ask one of our workshop hosts there. I'll be answering questions myself until the hackathon ends about the workshops. So yeah, hope to see you there, and I hope this workshop was really useful for you. Thanks.